Ma'am, a single reactant breaks down to give a simpler product.
Yes. Then we have discussed about displacement reaction, or we are going to discuss it. Displacement reaction, did I explain you in the last class?
No, ma'am, displacement.
Okay, so we had stopped for decomposition reaction. So we'll continue with displacement reaction. So what do you mean by displacement reaction? Okay, so displacement reaction, so that is always, so we'll consider a reaction. So you can see here zinc plus HCl giving you ZnCl2 plus H2, right? So what is happening here? So when a metal, so one metal which is having which is more reactive, okay, than the other metal, so that get displaced. So the metal which is more reactive get displaces by the metal which is less reactive from its compound or solution. Then it is called as displacement reaction. Okay, suppose, so there is an activity given in your textbook. So what is the activity? So take 3 nails. Okay, you have to take 3 iron nails and you have to clean them. And then how you have to clean them? So why you are cleaning them? So that if any rust is there for the iron, so you can clean it with the sandpaper. So you know the sandpaper, right? So sandpaper, why it is used to open the this, okay, for if the iron is rusted, so you can just clean it with the help of sandpaper. So what you have to do, you have to take 3 nails. So you have to clean it with the help of the sandpaper. So why you are cleaning it? Because if any rusting, okay, if there is any rusting of iron, so you to clean that, you have to okay, so for if any rust is there to the iron, so to clean, so you are using the sandpaper. So you are taking the 3 iron nails. Then what you have to do, you have to take 2 test tubes. Okay, you can see here in the diagram. So 2 test tubes are taken. So in the 2 test tube, you have to mark 1 test tube as A and another test tube as B. Okay, then in each test tube, you have to take around 10 ml of copper sulfate solution. So what is copper sulfate solution? It will be blue in color. Okay, copper sulfate solution, here copper is in +2 state, CuSO4. So copper will be in +2 state. So copper SO4 solution, that will be blue color, blue in color. So so what you are going to do? So that you are going to take in the 2 test tubes. So in both the test tube, you will be having 10 ml of solution. Okay, so this is what you are going to do. Then what you have to do, take 2 irons. Okay, take 2 iron nails and you have to tie it with a thread. So with the help of the thread, you have to tie it, and then you have to carefully immerse it. Immerse means what? You have to just insert it in one of the test tube. You can see here in the test tube. Okay, in the test tube, you can see that the nail, with the help of that this thread, you have to try it. Just a second. Okay. What you are going to do? You are going to take 3 irons. Just will glance once. So you have to take 3 irons. Okay. So to clean it, you have to clean it with the help of a sandpaper. Then take 2 test tubes. In 2 test tubes, you are going to take copper sulfate solution. Okay. Then mark 1 test tube as A, another test tube as B. Now next step is what? You have to take the 2 iron nails. Out of 3 iron nails, take 2 iron nails. Then with the help of the thread, tie it and immerse it in one of the test tube. Okay, in the you can immerse it in test tube number B. Okay, the iron nails, you have to immerse it with the test tube number B, and you have to keep the iron in the test tube for around 20 minutes. Now for comparison, the another nail you have to just keep aside it. Okay. Now what will happen after 20 minutes? So after 20 minutes, you have to take out the iron nails from the copper sulfate solution in which you are immersed it. That is in from the test tube B. Okay, that is from the test tube B. You are going to remove the iron nail and you have to just see the color. Now, what is when you're comparing the color? So what did I say? That copper sulfate solution, it is blue in color, right? So copper sulfate solution is blue in color. So after you are immersing that iron nail in the test tube number B, you can see that the color has been changed. The color changes to green color. Okay, the color, the intensity of blue color, it changes to green color. Okay, so after comparing the color of the iron nail which is dipped in the copper sulfate and that with the test tube number A. In test tube number A, we have not done any changes. We have not added any iron this. Okay. Okay, so you have to, so what you are going to do, you are going to put the iron in one of the test tube. So in A, you have not added any iron nail. Okay, in B, you have added the iron nail. So what is your observation in test tube number A? Okay, in test tube number A, the solution, it remains blue itself. It remains blue itself. Okay, because the solution is of copper sulfate. And in test tube number B, which you have left with 2 iron nails, it turns to green color. Okay, why it turns to green color? Why is the why does the nail it the nail becomes, and the nail which was cleaned? Okay, so no, you have seen that the nail, if it is if it is untidy, we have cleaned it with the help of sandpaper. But when you dip it in the test tube number B, the iron, okay, the iron which is steel, you can see here, okay, how the color would be, it changes to dark brown color. Okay, why is it so? Why the color changes here? So it is because of the solution. Okay, in iron means what? It is Fe, right? Fe. So your Fe, it get that copper solution, what it consists of? Cu. So the Cu ions, it gets replaces by Fe. Okay, so thus the iron, the solution turns green, and the iron, okay, so the copper ion, it becomes a dark brown. So this is the displacement reaction. So always the more reactive element, what it will happen? It will get displaces with the less reactive element from its compound or solution. Okay. So what we have seen? So one solution, we have not dipped anything. Okay, we have not dipped anything. So the copper sulfate solution, it remains as it is. The copper Cu plus ions, because of the presence of Cu plus ions, it remains blue itself. The color remains blue itself. But in the another test tube where you have dipped the iron nail, what happens? The iron nail, iron means it consists of Fe ions, right? If it consists of Fe ions, thus Fe, it gets replaces with the copper ions from the solution. Okay. So this is the displacement reaction. So in this reaction, what is happening? The iron has displaced, or it is removed. It is removing the another element, that is copper. Okay, from copper sulfate solution. So iron, what it is doing? It is displacing the copper, that is another element, copper, from the copper sulfate solution. So thus this reaction, or this type of reaction, is called as displacement reaction. So here is that example. Okay, here the reaction is written here. You can see it. So when the iron reacts with copper sulfate solution, it forms iron sulfate and copper metal. So Fe plus CuSO4. So Fe is solid. Okay, the iron which we have taken, it is in solid state. Then copper sulfate solution, it is aqueous solution, because we have taken the aqueous solution. So it is aqueous state. Then what is happening? Your iron, okay, the iron, it is getting displaced by copper or copper metal, okay, copper element. Thus it becomes FeSO4. So it get displaces by FeSO4, and your copper remains deposited on the nail. Because of that, it gets brown color. Okay, so this is the displacement reaction. So this is first reaction. Okay, so this is one of the example for displacement reaction. So always whenever the metal which is of higher reactivity, okay, so that gets displaced by the metal which is having less reactive in nature from the compound or its solution. So this is the first example for displacement reaction. Okay, Then the second displacement reaction, which is given here, that is when zinc. So zinc is here a solid, and your HCl is what? It is a hydrochloric acid, concentrated hydrochloric acid. So when you pass zinc with hydrochloric acid, your hydrochloric acid, that is your chloride ions, okay, they get okay, so your chloride ions, they get displaced with Zn. So it forms ZnCl2. Okay, so it gives hydrogen gas. So your H2, it gets into H2 gas. So Zn, which is in solid state, plus 2HCl. Okay, 2HCl, it gives you ZnCl2 plus H2. So like this is the reaction. So whenever zinc, it reacts with hydrochloric acid, it gives you what? It gives you hydrogen gas and zinc chloride. So this is the another displacement reaction. Okay. Then one more reaction you can see that zinc. Okay. If you take a zinc, so another examples of you can just write down. Okay. Examples, if you know as many as possible, that is good. So zinc. So zinc, which is solid state, which reacts with copper sulfate. Okay. Which is in aqueous state, giving you ZnSO4, which is aqueous, plus your copper solid. So here, if you dip a zinc rod into copper sulfate, what happens? The copper, it gets displaces, and your zinc, it gets displaces by another element, that is copper. So zinc sulfate is formed. Okay, so like this is another displacement reaction. Okay, one more reaction with PBS. PBS is what? Lead sulfide. Okay, it is lead sulfide. So lead sulfide, that is Pb. So Pb, that is lead, it reacts with copper chloride. Now copper chloride is also a aqueous solution. So here copper, can you tell me what is the state of copper here? Can you tell me what is the state of copper? Yes. Chloride -1. So there are 2 chlorine atoms. So 2 chlorine atoms means it is -2, right? So copper is +2, right? So copper is +2. So like this. So copper is, it is +2. Okay. So the oxidation state is +2. So here, so what happens? Lead, it reacts with copper chloride aqueous solution. And what happens? Your Pb, okay, your copper gets displaces by lead. Okay, so it forms PbCl2, that is lead chloride plus copper. Okay, so this is another reaction for displacement reaction. So these are the examples for displacement reaction. So one of the element which is highly reactive, it gets displaced by the element which is less reactive from its compound or solution, is called as displacement reaction. So here you can see that zinc. So in this both the cases here, zinc and lead. So these are more reactive than copper. As they are more reactive than copper, so these elements are getting displaced by lead. Okay, they are getting displaced by copper here. So zinc and lead are more highly reactive than that of copper. So because of that, they displace the copper from its compound. Okay, so this is the example for displacement reaction. Understood? What are displacement reaction? Yes.
Yes, ma'am.
So next we'll go to double displacement reaction. So what do you mean by double displacement reaction? Now suppose I take two. So again, if I take 2 test tubes here, okay, you can see here 2 test tubes are taken, right? 2 test tubes are taken. So in both the test tubes, you add 3 ml of solution. Okay. So in one test tube, you take 3 ml of sodium sulfate solution. So Na2SO4, that is sodium sulfate solution. And in another test tube, again, they have taken 3 ml of barium chloride solution, that is BaCl2 solution. Okay. So what is done? Two test tubes are taken. Okay, two test tubes are taken. So in one test tube, you take sodium sulfate solution. In and another test tube, you take barium chloride solution. So both the test tube consist of 3 ml of solution. Okay. Now what is done? So if you so first step you have to take in separately. Okay, in both the test tube you have to take separate the solution. Then what you have to do? Take a beaker. Okay, take a beaker and add both this test tube in this. Okay, you have to mix it. You have to do mix. Okay, you have to mix it. Okay, mix the two solution. Then what do you observe? So after you add both the solution to the beaker, what is observed is it forms a precipitate. So here you can see barium chloride and another is what? Na2SO4, right? Sodium sulfate solution. So it forms a precipitate of barium sulfate. Okay, barium sulfate. So what is getting displaced here? So here double displacement reaction means here you can see. So here the reactions in which ions are getting exchanged between two reactants. So between the two reactants, the ions, these are called as ions, right? SO4, that is sulfate ions. Then barium, Ba plus 2, these are ions. So between the two reactants, so these are called as reactants. So across the this, okay, arrow mark. So left hand side of the arrow mark, they are called as reactant, and right hand side of the arrow mark, they are called as what? They are called as products. So left hand side of the arrow mark, they are called as reactants. So the reactions in which the ions, okay, these are called as what? These are called as ions. So there is exchange of the ions between these two reactants, okay, forming new compounds. So they are called as what? They are called as double displacement reaction. What it is called as? Double displacement reaction. Because between the two ions or between the two compounds, what is formed? Between the two reactants, there is displace or there is exchange of the ions taking place. Okay. So what is happening here? So when you add, so when the solution of barium chloride, it reacts with the solution of sodium sulfate. So white precipitate is formed. So when you mix these two solutions, okay, you form. So there will be a precipitate. Precipitate means it will be formed like a curd. Okay, you know curd. So it will be in the form of the curd. It forms a precipitate. So white precipitate, it gets settled down. Okay, it forms a curdy pipity. It is called as precipitate. Precipitate is nothing but it is called as like a curd. The appearance will be curdy. Okay, so it is called as pipity. In short, it is called as pipity. So always, so when the solution of barium chloride, it reacts with the solution of sodium sulfate. So white precipitate of barium sulfate is formed along with the sodium chloride. This sodium chloride, it will be aqueous solution. Okay, you can see here. Okay, here you can see in this diagram. So both the solution, so from the both the test tube, the solutions are added in the beaker and a white PPT. White PPT is nothing but a precipitate which is in the form of curd. Okay, in the form of curd, it is formed at the bottom. So it is the precipitate which is formed. It is of barium sulfate. Okay, the ion is getting exchanged between the two reactants. So barium, it exchanges the Cl with sulfate. So barium sulfate is the product and okay, and NaCl. So these are the products which is formed. So this is double displacement reaction. Okay. So this is double displacement reaction. So this is first example of double displacement reaction. Why it is called as double displacement reaction? The earlier you have studied it is displacement reaction. Okay, this is double displacement reaction. Why? Because there is exchange of two ions between the two reactants. So you can see here. So earlier you could see that there was only exchange of one. Okay, earlier you have seen that there was only exchange of one ion from the reactant. Here there is exchange of two ions from the reactants. Okay, so it is called as double displacement reaction. So next example is understood. This example is clear. Example is clear?
Yes, ma'am.
Okay, so the next example is for of sodium hydroxide. Okay, so I'll just clear this. So sodium hydroxide. So sodium hydroxide, it is a base. Okay, sodium hydroxide is base. What is base? What do you mean by base and acid? What is the simplest definition of base? What is the simplest definition of base? What?
Ma'am, it's bitter in taste.
What?
Ma'am, base is actually bitter in taste.
Huh. Okay, you're telling about property. I just wanted a definition for base. Acid and base. Okay, so what is acid? I'll just come with acid. Okay, so what is acid? Whose pH is below 7. Okay, whose pH is below 7. So less than 7. So whose pH is less than 7, it is said as acid. What is base? Whose pH is more than 7. Okay, whose pH is more than 7, that is 7.1 onwards. Then it is called as base. Okay, up to 14. What is acid? So acid, it is a negative logarithm of H plus ions. Okay, when it has H plus ions, so it is a negative logarithm of H plus ions. So when it has H plus ions, okay, H plus ions are more, then it is called as acid. What do you mean by base? It is a negative logarithm of OH minus ions. Okay, OH minus means it is hydroxyl ions. So this is the definition of acid and base. Okay, so acid whose pH is less than 7, base whose pH is more than 7. Okay, it is more than 7. It is more than 7. So it is said to be more than 7. Okay, and then it is called as base. So in acid, we consider the H plus ions. Okay, we consider H plus ions. And in base, we consider the hydroxyl ions, that is OH minus ions. So this is the simplest definition for acid and base. Okay, then so here what they have taken, sodium hydroxide. So it is a sodium hydroxide is a common base. Sodium hydroxide is what? NaOH. So NaOH, it reacts with hydrochloric acid. So hydrochloric acid is what? HCl. So HCl is a strong base. Okay, so hydrochloric acid and sodium hydroxide is a strong base. Hydrochloric acid is a strong acid. So it reacts giving you sodium chloride and water. So whenever, remember that whenever acid and base reacts, it gives you salt and water. It gives you what? It gives you salt and water. So whenever acid and base react, it gives you salt and water. NaCl is what? NaCl is salt. Okay, it is commonly it is called as NaCl is sodium chloride. So sodium chloride is a common salt, okay, which we use in our cooking, right? So it is nothing but sodium chloride, your daily common salt, right? Common salt is nothing but your NaCl. So NaCl. So always when acid and base reacts, it forms a NaCl and water. So here we have taken a strong base, that is NaOH, and strong acid, that is HCl, okay, giving you salt and water. So this is the reaction. NaOH is aqueous, HCl is aqueous, giving you NaCl, that is aqueous plus water, okay, which is in liquid state. So this is what? Double displacement reaction. So this is second example. This was the first reaction for double displacement reaction. So in double displacement reaction, so here also you can see both the ions are getting displaced. So Na is getting with Cl, right? NaCl it forms, and H2O, right? So this is H2O. So here H2O. right? H2O. So like this, okay. So like this, it is forming the two reactants. So the reaction in which the ions are getting exchanged. So here the ions are getting exchanged between the two reactants by forming new compounds. So they are called as double displacement reaction. Okay, so in this reaction, the ions are getting exchanged between the two reactants. So these are called as double displacement reaction. Clear?
Yes, ma'am.
Shreya, are you there? Shreya? Okay, understood. If you don't reply, I will understand you are there or no. Only two students are there. It's better you can just unmute yourself and you can answer in between. Okay. So these were some of the reactions. So we'll just see what all we have completed in the reaction part. Okay, so we have completed combination reaction. We have completed combination reaction. We have completed decomposition reaction. We have completed displacement reaction. Then we have completed double displacement reaction. Next is oxidation, reduction, and redox reaction. Okay, so next we'll see what is oxidation, what is reduction, and what is redox reaction. Any doubts still here? We'll continue. Shall I continue further?
No doubts.
Okay, fine. Shreya? Okay. So I'll start with the oxidation reaction. Oxidation. Okay, what do you mean by oxidation? Addition of oxygen. Okay, whenever there is addition of oxygen, it is called as oxidation. Remember, the simplest definition of oxidation is whenever you are adding the oxygen. Whenever you are adding the oxygen, then it is called as oxidation. Okay, and removal of here. You can see the definition here, which is written here down. Right, so your oxidation reaction. Okay, so addition of oxygen or removal of hydrogen. So addition, you have to note it down, okay? Important definition. So addition of oxygen or removal of hydrogen is nothing but your oxidation. It is nothing but oxidation. Okay, so this is the simplest definition. Or addition of non-metallic element or addition of oxygen or non-metallic element. Non-metallic element means what? Non-metallic element. No, halogens. Okay, halogens are non-metallic element. So halogens, they are called as non-metallic elements. So addition of oxygen or addition of non-metallic elements or removal of hydrogen or removal of metallic elements. Metallic elements means metallic. Okay, the elements which are metals like your lithium, sodium, potassium, rubidium. Okay, so these are all metals. So if you are removing the hydrogen or you are removing any metallic element, then it is oxidation. So remember, there are four definitions: addition of oxygen or addition of metallic element, non-metallic element, or removal of hydrogen or removal of metallic element is called as oxidation. Okay, so the simplest, don't get confused with all this. Just remember addition of oxygen. So whenever you are adding the oxygen, addition of oxygen, so in mind you keep it that the addition of oxygen means removal of hydrogen. Okay, it will be vice versa. So addition of oxygen is nothing but oxidation. Okay, and removal of hydrogen is oxidation. So addition of oxygen or removal of hydrogen is your oxidation. Understood? Then what is reduction? What is reduction? It will be vice versa. It will be the removal of oxygen and addition of hydrogen. Okay, so it is a removal of oxygen and addition of hydrogen is called as what? It is called as reduction. Okay, so always remember. So the easy way to remember is you have to remember in terms of oxygen. So your just I'll write here. So oxidation, reduction. Okay, so addition of oxygen. This is what? Addition of hydrogen. This is what? Removal of hydrogen. This is removal of oxygen. Okay, so the easy way to remember. So oxidation, addition of oxygen, removal of hydrogen. Reduction is addition of hydrogen and removal of oxygen. So this is the definitions for oxidation and reduction. Now, what is redox reaction? Okay, now we'll see one example first for oxidation. What is the first example for oxidation? Oxidation, okay, I'll write the example for oxidation here. Example for oxidation is copper, okay, Cu plus giving you 2Cu. So what you're doing, you're adding your oxidation. So you're adding oxygen. Oxygen means what? It is undergoing a oxidation reaction. So you're adding oxygen to the element. So it is undergoing what? It is undergoing a oxidation reaction. Now you have to tell me what type of reaction is this. Yes. What type of reaction is this?
Displacement reaction.
No. Now in terms of oxidation and hydrogen, we are talking about reduction and oxidation. No, just now I gave the definition. What is oxidation?
Reduction.
This is reduction. Okay, so this is reduction. Whenever you are adding hydrogen, then it is reduction. Here you have added what? You have added oxidation. So it is oxygen. So it is called as oxidation reaction. So whenever you are adding oxygen and hydrogen in terms of oxidation and reduction, so you are talking about what? You are talking about in terms of oxidation, oxygen and hydrogen. So whenever you are adding oxygen, then it will undergo oxidation reaction. And whenever you are adding hydrogen, then it will undergo reduction reaction. Now, what is redox reaction? Okay, the next reaction, it is called as redox reaction. What do you mean by redox reaction? Redox. Okay, redox means redox. So I can just split it up here. You can see redox means what? Reduction and oxidation. So simultaneously, when in the reaction, okay, in one reaction, now you have seen in oxidation and reduction different reactions. Just now I gave you one example each. So you have seen a separate examples, that is copper plus O2 giving you 2CuO. Then another was CuO plus H2 giving you Cu plus H2O. So these are the two different reactions. So this is oxidation reaction, this is reduction reaction. Now in one reaction itself, okay, in one reaction, a reaction wherein simultaneously oxidation as well as reduction takes place. So redox means what? Reduction, okay, and oxidation. So in a reaction where simultaneously reduction and oxidation takes place, then it is called as a redox reaction. So I'll give you example, CuO plus H2 giving you Cu plus H2O. Okay, so here what is happening? Here you have to heat. Okay, so here what is happening here? So this copper CuO H2CO. Okay, you are adding what? You are adding your hydrogen. You can see here, you are adding hydrogen here. So this is getting converted to Cu. So this is a reduction reaction. And here H2, what is happening here? H2 is there and there is addition of oxygen. So this is what? This is a oxidation. So simultaneously in the reaction, one is undergoing oxidation and another is undergoing reduction. So simultaneously in a reaction where oxidation and reduction both takes place simultaneously, then it is called as redox reaction. Okay. So we'll revise it for today. I think it will be confusion if we go further. Okay. So first, what is displacement reaction? What is displacement reaction? One of the, so the metal which is having more reactive. So in both the metals, okay, in the reactants wherein one of the, okay, so the element which is more reactive gets displaced, okay, with the element which is less reactive from its compound or solution, then it is called as displacement reaction. Okay, so we have seen two examples. So wherein the first example was with copper sulfate solution. So one copper sulfate solution, it remains as it is. Why? Because you did not dip any iron nail in that. But in another test tube of copper sulfate solution, you had dipped a iron nail. So what is happening there? The iron, the copper, okay, so the iron get displaced by the copper ions, okay, and it forms what? Iron sulfate. So this is the displacement reaction. So the element which is more reactive, it gets displaced with the element which is less reactive from its compound or solution. Okay, so then, so it is called as what? It is called as, so it is called as displacement reaction. Okay, so this is displacement reaction. Then what do you mean by double displacement reaction? Double displacement reaction means a reaction. Okay, now in a reaction, you can see here in displacement reaction, what is the change in displacement and double displacement? Now here you can see in a displacement reaction, only one of the this, okay, here you can see copper sulfate. So only copper, what is getting exchanged? Fe is getting exchanged with your copper, right? Only Fe is getting exchanged with your copper sulfate. Okay, here like this. Right, so it is forming what? FeSO4. Right, so your only one ions, okay, the element which is more reactive is getting displaced with the element which is less reactive from the reactant side. So only one single displacement is taking place. Okay, so it is called as displacement reaction. Then the next is what? Double displacement. In double displacement reaction, you can see this is a reaction. Now you know what is reaction. How do you write the reaction? What are the rules to write the reaction? Now in a reaction, okay, across on the left hand side, it is called as reactant. So between the two reactants, so anything to form a product, there should be two reactants, right? So 1 plus 2 will only give you 3, right? That is your product. So these are the reactants. So between the two reactants, when both the ions, okay, they will be having ions. So the ions are getting exchanged between these two reactants, which is forming the new products or new compounds. Then it is called as double displacement reaction. So here you can see that is Ba, is getting okay, that is Na is getting displaced with Ba. So it is forming what? BaSO4, and another this is what? That is NaCl. So another is NaCl. So like this. So double displacement. Two products are formed here. Two ions are getting exchanged. So it is called as double displacement reaction. So we have seen two examples here, right? We have seen two examples. So it is called as your double displacement reaction. So this is the simplest, what you can say, difference between the displacement and double displacement reaction. Then we had started with oxidation reaction. Okay, what do you mean by oxidation and reduction reaction? Oxidation, reduction. Now oxidation means what? Addition of oxygen. addition of oxygen. Reduction is removal of, or you can write here in terms of oxygen only. Okay, then it will be removal of oxygen, and this is removal of hydrogen. This is addition of hydrogen. So this is in terms of oxidation reduction. Remember the simplest definition. Okay, so this is oxidation reduction. Now what is the next reaction is redox reaction. Redox. The word itself, redox. Okay, you can see here. Redox is what? R-E-D-O-X. Redox. So if I split this word redox into this redox. So in a reaction wherein simultaneously reduction and oxidation takes place. Okay, oxidation and reduction takes place simultaneously. It gives to rise called as redox reaction. So a single reaction wherein both oxidation and reduction takes place simultaneously, then it is called as redox reaction. Okay, so you can see here. So when copper, so here what is added here? CuO plus H2. CuO plus H2 means it is a redox. What is it? It is a reduction because there is addition of hydrogen, and here H2. Okay, and here it is H2O. So there is addition of oxygen. So it is called as oxidation. Understood? So a reaction, a single reaction wherein both oxidation and reduction takes place simultaneously, then it is called as redox reaction. Understood?
Yes, ma'am.
Okay. So now what is reducing agent? Now this is oxidation reduction. Now you understood what is oxidation, what is reduction, then what is redox reaction. Now, now the next term is what? Next term is reducing agent. The substance which gets oxidized is called as reducing agent. Okay, the substance which gets oxidized. So the substances which gets oxidized is called as reducing agent, and the substance which get reduced is called as oxidizing agent. Okay, so just you have to remember this definition. Okay, understood? So the substance which gets oxidized, the substance which gets oxidized is called as reducing agent, and the substance which gets reduced is called as oxidizing agent. So these are the definitions here. Okay, so in this reaction you can see here, so the explanation for this reaction, above reaction, so CuO is changing to Cu. So oxygen is being removed. So here you can see there is removal of oxygen. Removal of oxygen and addition of hydrogen is nothing but your reduction. So, and removal of here where H2 to, so here removal of oxygen from substance is nothing but reduction. Now here what is happening? There is addition of oxygen from H2 to H2O. There is addition of oxygen. So it is called as oxidation. Okay. So this is the simplest definition for oxidation and reduction. So, okay. So here in this reaction, so this was the first. Then in this reaction where H2 is changing to H2O. So what is happening there? Oxygen is being added to the hydrogen, right? So in this reaction, which reaction I'm talking about? This reaction, H2, C2O plus H2O giving you Cu plus H2O. So what is happening here? From H2O, okay, to forming H2O. What is happening? There is addition of oxygen. Addition of oxygen is nothing but your oxidation. Okay, so hydrogen is being oxidized to water. So hydrogen is being oxidized to water. So it is called as oxidizing agent. Okay, so this is the definitions. I hope you have understood. So the exothermic reaction, endothermic reaction, and the remaining part we'll discuss in the next class. If you have any doubts, you can ask me. Yes, if you have any doubts, you can ask.
No doubts.
Okay, fine. Then we'll stop it for today. Okay, if you have any doubts, you can come in. You can just go through whatever we have. I think another 2 classes we require, or 1 class to finish this. Okay, we have left with very small parts. So another 1 class, I think 1 class. I'll just see. Yes, another 1 class. Okay, I'll finish this. Then after that, we'll discuss the question and answers. Okay. So next class, you have. I hope you are revising it daily. Okay. So next class, I'll be asking some questions. So be prepared. If you have any doubts, come up with the doubts in the next session. Okay. So we'll stop the class now.